Alright, so here is the worksheet that I have given you. Here are the formulas up top that we're going to be looking at. So looking at number 1, it says determine the centrifugal force acting upon a 40 kilogram child who makes 10 revolutions around the cliffhanger in 29.3 seconds. The radius of the barrel is 2.9 meters. So again, when solving for this, my suggestion is to pull out everything that you're given. So the mass of the child would be that 40 kilograms. We have the 10 revolutions in 29.3 seconds. So that's how we're going to be finding our time. So they give us the number of rotations and then a time. So in order to find that, that's going to be the time they give us, which is 29.3 divided by 10, the number of rotations. So the time that we are going to be using is 2.93 seconds. And then they give us the radius, 2.9 meters. And what we are trying to find is the centrifugal force, which we know as the net force. So looking at our net force formulas, we're going to see what we have. So do we have acceleration? No. They do not give us the acceleration of the object. Then we need to look at velocity. We are not given velocity, but we do have radius. And then we do have this radius and our time. So we're going to be looking at this formula right here. We have our mass. We have pi always, we have our radius, and then we found the time here. So this would be the force formula we would use because we have all of those formulas. So our mass that they give us would be 40 kilograms. We're going to be multiplying that by 4 pi squared. Our radius is 2.9, and that's going to be divided by our time, which is 2.93. And we're going to square that. So that is how you set up this formula. So the first thing that you want to do again is you're going to square your pi and you want to square your time. So go ahead and just get rid of those. So that's going to be 9.86. That's going to be 8.58. So we squared our two variables, and now we're going to simplify everything that's up top here. So we're going to do 4 times 9.86 times 2.9. So that's going to give us 114.3, round that to 8. So that will be your top number. We're going to bring over that 8.58. So we simplified everything up here. We brought over this number here. And now we're going to divide those two. And that's going to give us 13.33. And we are not done just yet. We need to make sure we take our mass and multiply it by that number. So that 40 multiplied by our 13.33. And your answer is going to be 533.22, and that will be newtons because it's force. So that's the first question. Now we can look at our second question. During a spin cycle of a washing machine, the clothes stick to the outer wall, and it spins at a rate of 1,800 revolutions per minute. The radius of the barrel is 26 centimeters. So again, we're going to pull out everything that we're given. We have the number of rotations per amount of time. So we're going to use our time formula again to find the time it takes for one rotation to occur. So time will be our time in seconds, so 60 seconds, divided by the number of rotations, which is 1,800. you're going to divide those two and get so that is the time that we're going to be using throughout this whole problem. And then they give us the radius, but notice that the radius is in centimeters. We need that to be in meters, so we're going to convert that. So 26 centimeters actually is 0.26 meters, so that will be the radius, the 0.26 meters. And it asks us to find a couple of things. It says determine the speed in which they are spinning, and then determine the acceleration. So our speed is going to be this formula here, 2 pi r divided by time, and we have all those, so our radius is, and then the time is that 0.033 seconds. So we have 2 pi r divided by our time, and we are going to simplify that top, so multiplying our 2 times 3.14 times 0.26. And then bringing over our time. And then finally our last would be to divide those two numbers together. And our velocity would be 49.48 meters per second. So that's the velocity. And then the last thing they ask for is the acceleration. So we need to look at our acceleration formulas. We have velocity squared divided by radius, or we have 2 pi r divided by time. So we just found our velocity, so we can use this variable now, and we do have our radius. So our acceleration will be our velocity, which is 49.48. And don't forget that will be squared divided by the radius, which is 0.26 meters. The first thing you need to do is square that velocity first. And you're going to get 2,448.27, and then bring over the 2.6 meters. And then you're going to divide those two numbers. And your acceleration is going to be 9,416.42 meters per second. So that is your velocity here and your acceleration. Let's move to number 3. Alright, so looking at number 3, we have New York boats are having the fastest boasts that they're having the fastest carousel in the world. We have the riders that spin 8 meters per second, and the radius will be 7.4 meters. And we want to determine the time, and then we want to determine the acceleration of the riders. So looking at what we are given, we have our velocity here. And then we have our radius here, 7.4 meters. We want to find the time it takes for the riders to complete one circle. And we usually use this formula for time, but we have velocity and we have radius. So we want to look at the formula for velocity or speed, because we have our radius, we have our speed, and we can rearrange it to find our time. So that formula is going to be time equals 2 pi r over the velocity. And again, that's just rearranging. If this were a triangle, 2 pi r would be on top, velocity, and time would be on bottom. So if you cover up time, it's going to be that 2 pi r divided by your velocity or your speed. So we're going to find time by using this formula here. 2 pi, our radius is 7.4, and the velocity that they give is 8 meters per second. So you're going to multiply these two top numbers together. So 2 times 3.14 times 7.4 will give you 46.47, and then bring over that 8 and divide those two numbers, and you'll get 5.8 seconds. So that was your time. And then we want to look at determine the acceleration. So we can look at our acceleration formula as velocity squared divided by radius, which is what we have. So we can go ahead and find that. So our acceleration is our velocity, which is 8 squared divided by our radius, 7.4. 8 squared is 64. Bring over the 7.4, and you're going to divide those two numbers together. And you'll get 8.65 meters per second per second. And then finally we have our last one here, number 4. We have a CD-ROM claims that it can spin a frequency of 120 revolutions per minute, and that is all they give us. And they want us to find what speed, and then they want us to find the acceleration. So first we're going to take this. We have 100 rotations per minute. So we're going to be using our time formula and use time divided by the number of rotations to find the time it takes for one cycle to occur. So time is going to be our time in seconds, which is minutes, 60 seconds, divided by the number of rotations, which is 1200. So divide that and you're going to get 0.05 seconds. So that's the amount of time it takes for one cycle to occur. Then it asks for the velocity, which we have here is the radius that they give us, 5.6 centimeters. Again, if it's centimeters, you're going to convert that to meters, which is 0.056 meters. And we're going to plug that into our velocity formula up here. So 2 pi, our radius, which is 0.56, divided by our time, 0.05. You're going to multiply your top numbers together and divide by that 0.05 to get 7 meters per second as your velocity. And then finally, looking for acceleration, we are going to be looking at our acceleration formulas. We have our velocity, we have our radius, so we're going to use that formula. So 7 squared divided by our radius, which we found is 0.56. Make sure you square your velocity first and then divide it by to get 875 meters per second per second. That is your acceleration. And that is it.